This is Unit 7-3, the Fundamental Theorem of Calculus. Now, the definition of the Fundamental Theorem of Calculus is basically something that you probably already know, okay? And the definition is basically saying the following, that say we've got the integral from a to b of f of x dx. That is simply equal to the integral evaluated at b, which is represented by capital F of b, minus the integral of the function evaluated at a, okay? So this is something we basically used already, but it is referred to as the fundamental theorem of calculus. So where might we use this, okay? One of the places would be in an example such as this. Calculate the area of the shaded region. Notice the red shaded region is created by this function y is equal to x squared, and the blue region is created by the function y is equal to 2 minus x. Okay, and it goes everywhere from x equals 0 to x equals 2. So the first thing we want to determine is what is the area of the red portion, okay? That's this first area right here, and we want to find out what is the area of that. Well, we're going to find that by saying the integral from 0 to 1 of x squared dx, all right? Now, to that area, I want to add the area of the blue portion here, okay? That's this portion over here on the right, all right? So I want to calculate that area and add it to the red area, okay? So that is simply the integral from 1 to 2. Notice we start here at 1, and we go as far as 2, and we're bounded by y equals 2 minus x. So it's simply the integral from 1 to 2 of 2 minus x dx. And the whole thing now is what we originally were asked is simply the integral of the red portion, which is this piece right here, plus the integral of the blue portion, and we add those up to get the area of the entire shaded region. And if we take the integrals, we notice that x squared becomes x cubed over 3, and that 2 minus x becomes 2x minus x squared over 2. And we evaluate the first one from 0 to 1 and the second one from 1 to 2, and we add the two areas together. So if we do the calculations, we basically come out with 5/6 as the area of the entire shaded region. Now let's look at another example. Now this is a little bit of a different example. We're again calculating the area of the shaded region, but notice the red portion is actually below the axis, while the blue portion is above the axis. So the red portion is simply the integral from 0 to 1 of x squared minus 1. Remember, that's the function that defines that area, dx. Now, we realize, though, that that is below the x-axis. So if I calculate that, that's going to come out negative. Well, I want the sum of this, I want the area here. I don't want to deal with negative areas. I want, the total positive area of these two portions. So I'm going to have to do something there. And that is, I'm simply going to take the absolute value of this red area, and that will give me a positive number. And as in the previous example, I have to add the area of the blue portion, all right? So that's the integral from 1 to 2 of x minus 1 dx. So if I calculate the integrals in each of these cases, and plug in the values, the first one from 0 to 1, the second one from 1 to 2, and crank out the numbers, I come out with the calculated area of the shaded region being 7/6.